Kubernetes 1.26, another topic is traffic engineering advancements. So if I go to the Kubernetes blog, advancements in traffic engineering. So let's try to understand what exactly it is. So before that, I will step back and try to understand service and Servce IP. So this is a two node Kubernetes cluster, one master and one worker node, and which is 1.26.1 and Ubuntu 22.04 is a base image, container D this is one, and these are the one, and 192.168 is my cluster IP range, and as well as 100.64 is my pod cider range, right? So now I will try to create a deployment which is we have learned in the CKA, right? With the two replicas, right? Which is a simple, right? So my two pods are created. So kubectl get pod, then you will be able to see the two pods are created. Now what I will do is I will try to create a service kubectl expose. I am exposing this particular deployment as a web-spc on the port 3000. Type equal to load balancer. So when I hit enter and kubectl get all, right? So when I do that, two pods are running and one service and one deployment, right? Perfect, all good. And if you observe this particular service, right, it's given the cluster load balancer, and external IP will be appear when actual load balancer is created. And this is a 3000 is the internal port which I specified, and 30189 I have not given. This is a node port which is assigned by the Kubernetes system, right? So now, right, so what I will do is now kubectl, right, get all again. I will do kubectl describe service. When I do the describe, right, here name, namespace, label, selector, and all everything is okay. And endpoints, these endpoints are the basically these two parts, 146 145 146 on 3000. Perfect. So this is the kind of a front end, and these two are the backends. But there is an IP called a Servce IP. What exactly it is? 10 dot something, 10.1111, right? So 111. So but during the Kubernetes cluster provisioning, I have given 192.158, which is my cluster range, and pod cider range is 100.64. So 192 and 100. But why this 10.111 in the picture? 10.111 is taken from the API server, which is service cluster IP range, which I have not given, right? And how to prove that? So kubectl describe pod, and in the kube system namespace I am just trying to query the kube API server, right? Here this is the what the kube API server, right? And here if you closely observe service cluster IP range, which is 10.9600/12, which is a very big range, and here 10.111.158 is allotted just randomly. So now go back to the slide. I created one simple service which has endpoints, yes, agree, and is given a Servce IP. But why, right? Which is completely we don't know what is exactly this IP, right? So overall the concept is this is a Servce IP, means this is the service behind the scenes. Two parts are serving with the different IP address 100.64, right? And whereas this IP address is a kind of a front-end IP or a stable IP address or a virtual IP address, you name it anything, because, right? So whenever somebody hit this particular service by using its a DNS or an IP address, right, what happens, or the ingress controller or anything, what happens is internally the traffic will goes to these two pods, right? These two pods initially, these are the actual the serving containers, right? So there this particular IP address will be shown. So why this particular IP address is this is a virtual IP address, static IP, right? And this is managed by the control plane. Yes, that's what it means. Control plane means this particular API server, one of the boss, super boss API server is specifies this is the what the virtual service IP range, where which will be masked, which will be right, and it's kind of an abstraction. So this is a front end, but in the back end 100.64 will serve, right. And overall concept is here is a decoupling, right. So decoupling is here means like your endpoints are 100 dot something, right. These now today 2 pods, tomorrow you will expose to increase to 100 pods, but this is the what the a decoupled. So there is a decoupling. Whatever the pod IPs are completely secured, and whatever the your service IP range you give, which is a fake IP range, anything you can give, right. That's what the its overall concept of service IP, right. Now so what I will do is I will just clear kubectl get all, I will just do again, and kubectl get endpoints, right. So we know from the CKA that when you create a service, automatically an endpoints are created. Endpoints are nothing but what, this is a guy is a front end, these two guys are the back end. So this is a endpoint is a one of the resource, like a kubectl get pod, kubectl get deployment, something like a, it's a one of the API resource, right. kubectl API resources, right, and just search for the endpoints, right. You will be able to get the endpoint, right. Now along with the endpoints there is another concept, kubectl endpoint slices also is created. This is created 4 minute 46 ago, and this particular slice is created 5 minute 4 seconds back. But if you closely observe, service name web SPC, endpoint is same as the service name, 100.64, 145 and 146 IP. Endpoint slice is also created with the same service name, same 3000 port which I choose to expose, same endpoints are mapped. So here endpoint slices are mapped with the endpoints. So what exactly these endpoint slices, right. So what exactly the difference between these two? So let's try to understand this. So again endpoint, so this is an endpoint, right. Currently here the endpoint has 2 pods, and tomorrow 100 pods, 10 pods, right. And if pods created, deleted and recreated, deleted, recreated, right, what happens is when it is deleted, recreated, who is the guy will take care? This service has to take care, this endpoint has to take care and maintain all these endpoints in this particular somewhere in the etcd database. So the problem with the endpoint is it will be a big fat boy. So if you create 100 pods, all 100 points are 100 pods or will be mapped to this endpoint. So in order to overcome this particular endpoint specific problems, right, more scalable and efficient way, those slice is nothing but making a pieces. So these are the parts will be sliced and cut into the equal number of pieces with an object called endpoint slice. So here what happens is, here only one API resource which is maintaining the this many number of parts, here we are divided into the multiple chunks. So here the what is the problem, this endpoint resource become a very large big fat boy, and every time Kubernetes has to recreate, erase, say this is erased, recreated, so every time it has to maintain, refresh this. But if you use the endpoint slice, it's a more scalable way, and it's a topology aware. Topology aware is nothing but it's know where to route, which part to go, right, and multi-protocol endpoint that we will see in the further slides. Because of this endpoint there is a huge impact on the performance, because every time it will refresh, but here it will improve the performance and reduce the network latency. Because if traffic is hitting these two and this is getting refreshed, no problem, because this is a small chunk and this is a more expanded width. And by the way, you can create a maximum of 100 endpoint slices in a Kubernetes cluster. Of course you can increase in a Kube API server level, right. So if you look at the endpoint slices, right, I'll go back here, right, kubectl get endpoint slices and kubectl describe endpoint slices, and this is the what the my endpoint slice. So if you closely observe endpoint slices, endpoints are defined, right? Ports are defined, endpoints are defined, and one endpoint is this guy, another endpoint is this guy, right? And if you closely look at the its YAML, kubectl get endpoint slices, and this is the endpoint slice name -o YAML. So when you do that, right, so this is a YAML, right, and endpoints are the multiple endpoint and kind equal to endpoint slice, which is the same which I put here, endpoint slice. And the ports, of course, yes, these are the ports here, ports on 3000 I have exposed, right? So these are the endpoint addresses. So all endpoint slices are basically invented or introduced in order to achieve the network related benefits. So in short, endpoint slices are an alternate to endpoints. So here you see the endpoints and you have seen the endpoint slices, both are aware, but endpoint slices are topology aware. So basically where to route, where is the pod, and which is a where is the traffic should go when somebody hit the service, this guy will tell. And multi-protocol support means not only the TCP and where the other protocol also support, and more scalable, which is nothing but you can create a multiple endpoint slices and link with the service. So that's why more scalable, more extensible, and it will give you the more performance. And endpoint slices are automatically created, yes, right, whenever, so kubectl get all, right, when I created a service, then automatically endpoint slices are created, right? I did not create. Kubectl get endpoints, right? So along with the endpoint slices are also created and automatically, that's what I'm trying to say. And make sure with any service selector, so if I create a service with the proper selector, then only these slices will be created. If the selector is not matching, it won't create. That's one thing. And in short, endpoint slice is nothing but a group of references of a network endpoints. So here in the YAML file we have already seen, right, reference to what, 145 IP, right, and 146 IP, and these are the condition. This is a node, this is a target reference, this is a namespace, this is a pod. So it's a kind of a reference, a network reference only. What are the references? What protocol, what port number, what service? Something like a front end is connecting to the back end, something like that. This is an endpoint slice, right? Now endpoint and endpoint slices, this is quite good, but who uses this endpoint slices? So these are the endpoint slices we have created in the previous slide. So what happens is, under the hood, endpoint slices object is pointing to endpoint slice, which is nothing but each endpoint. So in the Kubernetes, who will take care of the traffic? One is a Kube proxy. Kube proxy is the only the guy who resides in every Kubernetes node, including a master node. If you have a one master, one worker, two Kube proxy pods are running. Behind the scene there is a daemon set. And also who will take care of the traffic? Another one is ingress controller. So these two people are referring the endpoint slice. Why? Because why these two people should refer? Because these two guys are the only the resources will take care of the traffic to hit these guys. So that's why these are the two are the consumers of the endpoint slices, right? So this is the what the endpoint slice entire YAML which we have seen here. This is in the black and white, right? So these are the one. And one thing here, these are the address 1, address 2 we have seen. Just note down here, serving equal to true, terminating equal to false, right? So ready equal to true, ready equal to false, right? So if you look at the status here, ready equal to true, ready true, terminating is false, right? Just make a note on this particular YAML. Now go back to the endpoint slice conditions. Let's say there is a Kube API server and endpoint slice is created, right? That we have seen. But under the hood, there is a controller called endpoint controller, which is internally maintained by the Kube API server. Kind of it's an admission controller, right? We know every worker node will have a kubelet, right? So here, whenever you go and try to create a pod, what happens is this Kube API server, you go and hit the Kube API server. Kube API server will talk to instruct the kubelet, saying that hey kubelet, create the pods for this particular guy. At the same time, what happens is endpoint slices are created, right? These endpoint slices, specific information will be taken by the controller, and this controller will update endpoint slices with this pod status. What is the currently pod is doing? Pod is running fine. That's why terminating equal to false and ready equal to true, and yes, traffic is serving. So means this controller guy which will update here. Why? With respect to traffic. Who will take care of the traffic? This guy. So that's how it's a endpoint slices useful in a 1.26, right? Now next, same thing, you created kubectl delete pod 1. I wanted to delete this pod. Then Kube API server will instruct the kubelet that hey kubelet, go and delete this particular pod. Then what happens is this admission controller will take the details and references and updates endpoint slice, saying that this pod is terminating equal to true and ready equal to false. This is not ready. So endpoint slice is aware that pod 1 is dead. So that's how at least endpoint slice will know that which is currently at this second, at this millisecond time, who is accepting the traffic. That's how the endpoint slices will help home Kube proxy, who will take care of the traffic to come inside the worker node. Next, step back to the again the service, right? So we have created the service which is something like this, right? Service, right? This is the word. So and my service type, what is the service type I have created, which is a type is a load balancer, right? And even though I have given a load balancer, so what I will do is I will just take a service kubectl get svc and web -svc and -o yaml. I just wanted to see the Servce YAML, right? So if you look at the Servce YAML file, closely observe, external traffic policy is specified as a cluster. So now go back to the server. So whenever you use a load balancer, type equal to load balancer, right here, in that case what happens is this external traffic policy equal to cluster will be in the picture. This is the word in the picture. So and external traffic policy has two different types. One is a local and second one is a cluster. So cluster is a default. So why this external traffic policy? Whenever you hit this particular service from the external source, nothing but you are hitting from the browser, which is completely out of the Kubernetes cluster, you are hitting the traffic. So this traffic is sourced from the external. And cluster, what is nothing but cluster? Whenever you define external traffic policy cluster, what happens is if you have a 3 different nodes, what happens is every time it will causes a second hop. Hop is a networking concept. If anybody from networking, please comment on the hop details. But what I know from the hop is a full completely round trip will happens whenever you define a external traffic equal to cluster. Means you hit from somewhere US to the one server is running in Singapore, right? So the traffic will go to the server and the cluster, service, pods and containers, the full completely round trip, and client and source IP address obscures, and which is causes the completely entire round trip. What this happens is this will cost to more resources in the worker nodes. And other one is a local is nothing but it will preserve the client IP address, which will reduce as the second round trip. So that's what we wanted, right? So this is one. Next, external traffic policy. Here we have seen the local and cluster. So when you specify local, what happens, right? This is a node pool, this is a node 1, worker node 2, something like let's consider the E case, and this is a EC2 worker node, right? And we know that every worker node will have a proxy and kubelet, right? Now there are pods are running, just a simple standalone pods. Just consider it as a nginx pod, right? Now there is a one person taken a browser and from external traffic, okay, not internal, and he uses a service as a load balancer, same like how I did just now, right? This is one. Then it will go and create a network load balancer, right? So like something like how I created, right? Something like this. Load balancer is created for me, right? Here when you create in AWS, it will create a ELB or network load balancer, and what happens is this will go and internally create a node port, right? So even though my type is a load balancer, but internally it assigned 30,189 as a node port, which I did not specify. Only the Kubernetes system internally it specified, right? And that node port, what it will do, it will go and talk to the first Kube proxy, because the traffic related matter, this guy is the take care, right? Not the kubelet. Kube proxy, what it will do, it will create an IP table, it will maintain the pod IP address and service IP address, and it will make routes, where to go, routes and all. This guy will take care, right? Now here all good. Next is, and of course we know the kubelet will talk to the pod in case of anything to be done by the Kube API server, which is a big boss. So here all good. With respect to service and type equal to load balancer, external traffic policy equal to local means your traffic is from the external sources, right? External traffic policy equal to local, whereas this service specific, there is another feature called health check node port along with the node port. So we know service will expose a node port only, but along with the service, when load balancer and external traffic policy equal to local, then you can specify health check node port as well. So what exactly this will does is, this will liaise with the Kube proxy, and this will get the information of the whether this particular pod is healthy or not. This Kube proxy will tell this particular health check node port, and it will tell this guy load balancer that this is a entire worker node is healthy. That's what and if you go back to the Kubernetes here and kubectl explain under the service.spec, right? And I will just scroll up here, right? So service.spec, right? Scroll down here, scroll down. External traffic policy, when you specify a local, there is a health check node port. So this is the value. So how to specify? Go to the Servce YAML. I wanted the traffic should come from external and health check node port 30,200, something like that you can specify, because in this port I put some health check related some stuff. So that's what it mean. So now same setup, which is 2 pods. So every worker node two pods are running, which is running on highly available. Let's consider that. And my traffic is coming from external, and I wanted to distribute traffic policy as a local. So here what happens is, so my worker node 1, this pod and this pod is completely crashed, and which is died, and somehow this health check is green, this health check is not working because 503, this is 200, right? So here what happens is, external traffic policy local, and whenever this worker node is die, then this network related, so when in order to inform network load balancer, what exactly the Kubernetes system will do is, it will go to the Kube proxy and check the each and every pods and get the information, and it will update the health check status and inform the load balancer that this entire node is not available. So here everything is good, but the problem is, in order to do this all the health checks and all, there will be a huge CPU and IO intensivity. It's lot more happening, and which is a huge burden. This is the problem statement. So in order to deal this particular use, this is a problem statement. In order to deal this more efficiently in the kubeproxy level, this is the kubeproxy level, right? There is a future gate which is a proxy terminating endpoints. This is what the introduced. And if I go to the blog, right, this is a right proxy terminating endpoint. This is a kubeproxy documentation, right? And if you go to the future gates, proxy terminating endpoint, right, this is the what the in the beta version by default it's a true. So and go back to slide here, future gates, proxy terminating endpoints true, right? And by the way, kubeproxy which runs as a daemon set, that we know already, right? So when you specify this, what happens here? If these particular parts are died, then only your kubeproxy will tell the health check node port that this node is completely not available, and load balancer will know that entire this worker node is not available, only this worker node only available. That's the way a traffic will be improved if you choose from the external traffic policy as a local. So that's what the we can leverage the 1.26 feature, which is proxy terminating endpoints. Now so far we have seen the case for external traffic policy equal to local. Now let's try to look at the internal traffic policy. So why the internal traffic policy? This is applicable when you use a cluster IP, right? If you use a cluster IP, all the this particular option is comes into the picture. Again, this will have two options. One is a local, right? Other one is a cluster. So this is specifically for the cluster IP as we just shown. And why this is internal traffic policy? Again, even though if it is a internal or external, this kubeproxy is a take care of the network traffic and all, right? So this will tells the local endpoints that which is available, and these are the two, local and cluster. If it is a cluster, means it will consider all the endpoint, which is something like a round robin. In my Kubernetes cluster, let's say in highly available 3 availability zone, it will consider all endpoint, right? In case of local, it will be sent to only available endpoints. So now this is what my setup, just a simple 2 pods are running and kubeproxy, kubelet, etc. This is a 2 node highly available, right? If I create a by default service is a cluster IP, and I wanted to specify the traffic should be coming from the internal traffic, not the external, right? So what happens is, here the internal traffic policy I specified as a cluster, which is round robin, right? So whereas kubeproxy will read this particular service and service specific endpoint slice, endpoint slices, etc. What it will does, it will distribute the traffic randomly by reading the endpoint slices internally, right? That's what we initially learned, and distribute the traffic to the this particular pods. This is in case of the cluster. In case of internal traffic policy as a local, and here in this worker node, these 2 pods are not running, not healthy. So when I create a service with the internal traffic policy as a local, then the kubeproxy will take a references of this one and distribute the traffic to only this is available endpoint. That's what it means, the local. And whereas here there won't be any traffic will goes to this one. So the overall idea is internal traffic policy and external traffic policy along with the kubeproxy setting, which is called feature gates, and as well as you can leverage the endpoints so that endpoints will update the particular status, right? That's what the service engineering it's telling. That's it for this particular session point of view. And by the way, all the documentation which is available here and Kubernetes cluster and various topics I have explained here, I will provide in the description. I hope you learned something new, and we are learning here. Thank you. Let me know what you guys think in the form of a comment. Thanks for listening. Bye bye.